Okay, the final video for this advanced channel modeling is to do the exact same project, except instead of using the natural channel, we're going to use a prismatic T channel, all right? So so basically we'll get up to step 2, 3, 4 are exactly the same. Nothing different on step 2 through 4, 1 through 4. And then step 5 is different. So then instead of doing step 5, we'll start with step 5T, 6T. Oops, that's supposed to be 7T, 8T, 9T, and then we'll run the project again. So let's just start with everything is good right now, except we need to convert this project from, natural channel geometry into a trapezoidal geometry. Or we need to change our cross sections to T-lines. So if I click Open Attribute Table and edit this, what I want to do is set the type to, again, this is a string. So we want open quotation, single quotation mark, capital T, closed single quotation mark, update all. And then whatever you want to do to your roughness value or your cross section name, whatever, doesn't matter. I'm going to click Save and I'm going to click Close, and that, as soon as I click Close, that is going to trigger a non-schematized system. Okay, so we go back to the non-schematized data. Now what I need to do is load the first cross section in the table, and as you can see, everything over here changes from a natural channel geometry to a bank elevation on the left, bank elevation on the right, width, depth, side, slope. Okay. So now what I want to do is I want to cycle through and pick up every cross section and get every cross section loaded into this table. So I'm just going to do that really carefully. You can't really see that anything changed because all I was doing was cycling it, and as I was cycling it, it was filling up a table with this null data. Now I can, let me get back to the thing before I forget. So we applied the T, name the cross section, do all that, cycle through the cross sections, and that will load up this table of data. Now I could, if I wanted, go through each individual cross section and put the width and put the depth and put the side slope, but there's, a lot of them, so that would be a complete waste of time. So instead, I will come to the user cross sections, the user cross section T, and open the table. And because I cycled through all of those cross sections, I have a full table full of data, 22 cross sections. If I click Edit and change this to width, I can set the width to 28, which is the base width for the project, and click Update All. The depth is about 10 feet. Update All. The side slope starts out at about 0.5 for both the left and the right. Now, not every cross section is like that, but enough of them are like that that this is okay to do it this way to start with. Now I click Save, and then I click this guy right here to turn that off. And then when I come back over here, you'll see that this data has now filled this table. So you can zoom back through all your cross sections, and you can see that they're all fine. Okay. Next is to calculate the bank data for the cross sections. Okay, so the next step is to set this from grid to raster and just do all of them at the same time with this button right here. Click OK. And not only do we have more data in here, but we also have a plot. So if you scan down through this plot, and what are we looking for? We're looking for banks that don't seem to be the right elevation. Okay, so let's go ahead and put this on center, and then we'll zoom in, and then we'll come down here and see why is this not quite what we want it to be. Okay, So let's see if we do, and it's the same process, right? You hit enter, you hit edit, and you maybe just put that a little bit closer to the edge so that it's picking up a little bit more of that data. And then you just schematize or hit it again, and you, as you can see, it brought it up a little bit. We'll see if we have any more that have that same problem. This one has a little bit on the right. I'm not concerned with that one because if you can see right there, that is the right bank. Okay, that one looks fine. And then we're just following the rest. Oops. That one's just not, it's just flat up there, so it's not really gonna, oh, I'm on the wrong one, aren't I? Okay, let's, okay, I'll give it a little bit. Not much going on there. Not really gonna be able to fix that. This one, and that. Okay, so they all look pretty much okay. We'll take a look at the slope for them in a sec and save, and let's go back here. I don't want to make sure I don't skip anything. Okay, now we're going to add the transitional geometry, I think. So sample the bank elevation, and yeah, now we'll add the kind of the better geometry. Yeah, okay, let's do that now. Okay, and this one we'll use the table for. So let's go ahead and go to our 1, 2, 3, 4, 5, 6. Okay, this one, let's go ahead with a, well, use a measure tool. Kind of get that that bed elevation there. It's 55 or 60. So 60, and the slope is not quite the same as it was before. Okay, so that one's easy. And we'll just kind of do the same thing to this one. Okay. Now let's go to the next one. Okay, same thing. We'll just be uniform. Okay. And okay, this one, let's just say let's see what we got here. Say 70. And the left is like 1, and the right is 0.1. And this one, okay, that might be closer to 2. And that's 90. Or that, and again, that's probably closer to 2. Yeah, okay. So give you an idea. And let's see what's next. So then we do our, looks like I did 70, 100, 115, 121. Okay, I can do that. No, wait, that's not right. This one's 115. And that one's 121. Did I do that right? 70, 100, 115, 121. Let me do that again. Okay, 70. 100, 115, 121. Okay. And we might have to do some interior interpolating between them. Let's see. Okay, so schematize button is a great reset button. Remember that. Okay, so now we schematize the channel, or if you want to do a backup, you can do that right now too. So you schematize the channel, and that will fill out all the trapezoidal data and kind of replace all that natural data. So the schematize is the same. That's this guy here. And that will replace the trapezoidal, the natural data with trapezoidal data. And then the next thing you'll want to do is run the other interpolator. This is the prismatic interpolator. So you run that, and that interpolates the prismatic data. It's basically just the bank data. So if you come in and you see your T schematized data, you might, let's see if I come in here. Yeah, this is the one I want. What you might see, oops, is that you are getting interpolated bank data, which is pretty sweet, but you're not really getting interpolated this stuff. So what you'll want to do is, let me see, go back in here. I might have to open that back up. But so like between here and here, it just starts at 60. It's not interpolated. So let's look at this data. Let's see, grab this and we'll grab the channel cross section, and that is 28, still 28. Okay, then let's go down, 28, still 28, still 28, still 28, still 28, still 28, and that is 60. And then on this one, it'll go 60. Wait a second, that should be 60. Hang on a sec. Let me check this data real quick. Oh, I know the problem. I lost it. Okay, I just lost it. I didn't put it in there correctly. Okay, and then I should uncheck that. Okay, all right, so let's try that again. So if I go here and I just check out that cross section, see that's still 28. And that's 60. So it's not really right. It's not really what we want. And then if we do the other one, we go down again to this one. That is now 60, but it will stay 60 until it gets down to the next one, which tells it to be 28. So it's not really interpolating it correctly. So it might be something to, consider when you're doing your own data. So let's just go in here and, oops, sorry about that. I didn't mess that up. After you're 100% certain that you're not going to make any more modifications to your channel, you come in here and make sure this is sorted by 1, and then just go find the first 60, which is right here, and then just go in here and let's just go 40 and 30 or something like that, or 45, 35, and then 28. So 45, 35, and oops, that's not a 3, and then 28. And then same thing on the other side, 45, 35, 30, 28, and then just maybe, because we know it didn't go down that long anyway. Same thing on the next one, right? You go, same thing, it'll be 35, 45, 60, and then 60, 45, 35, 30, and then 28. And that one's not as bad. And then on this one down here, it's probably okay. So we could go maybe like, it's going up to 115. So here we could go like, we could say this would be 80 or 95, and this could be 80. Sorry, not 95. So that one's no big deal. And then maybe here, this could be 112, or let's see, that's 105, and maybe 109. Okay, on these ones, that's 115. We could go maybe like 117 and 119. And that would be pretty, and the depths didn't really change. And these guys are, maybe these guys are probably okay. They're probably fine, the slopes. So that would be easy way to kind of interpolate those, since they don't really interpolate themselves, unfortunately. Maybe I could get them to get my guys to get those to interpolate. That would be nice. Then you just save that and you close it, and now you have your transitions. Okay, let's see what's next. So after you interpolate, and that is it. That's the next thing. So then you go on to step 10 to finish the lesson. So that gets you back here to channel boundary, which we already did, culverts, which are done, export the channel, run the animation. So let's do that. Let's try that. So let's see, what we need is, we already have inflow outflow nodes, so we don't mess with any of that. We don't need culverts or any of that. What we need is a new folder. So new folder, lesson 2 advanced trap export. And let's get a quick look and see what this gives us. So don't need to turn on anything here, because I don't have any extra switches or anything. So it's basically just export and select the folder, hydraulic structures, Manning, topo, and then export it. Chanbank.dat. Okay, let's take a look and see what it gave us, because since I didn't start that from scratch, I just want to make sure that our we don't have any like leftover end data in here. Yeah, that looks fine. Yep, looks good. All our data's in there, looks good. Nothing weird about that. So let's see if it'll run. I'm a little concerned that it might need one of those banks to be adjusted because of those values, but let's just see what it says. Oops, that's not what I want to do. Good grief. Good thing I didn't click OK. Okay, that's, yep, there we go. Now we just wait for it to run it through its test, and we're going to checking the bank width. Okay, the bank widths were fine. And while it's running, looks like it's going to be okay. So while it's running, I'll show you a little bit about how to get those geometries. If you want to use a prismatic channel, but you're not sure what geometry to use, but you have a good LiDAR data, you can use the profile tool. Sorry, we need this guy. And you can say, so that starts at 82 and to 49. So you just 82 minus 49 gives you about, well, it's not quite 28, is it? That's about 33. Oh, so I have it a little off there. Let's try another one. So it might be a little low on my channel. I might need it to be a little bit wider. Let's try this one. That's 86 to 59. And that's 27. So yeah, it's back to something that I anticipated it to be about 28. So do that 4 or 5 times. And then, whenever you need your transition, do it in your transition. And you can also, when you do that, you can also like do it by slope. I think it'll do the like, for example, if you were looking for the slope of something, hang on a sec, there's something in there that it's picking up. Let's try it up here a little bit. And then you can calculate the slope off of this line because you have your max elevation, your min elevation, and your length of the line. So you could know your slope from this line. You can get some of the geometry details from this line. Let's see what we can get. Settings. Somewhere in here you can do it by slope. And so instead of giving you like it'll give you the slope. But anyway, it's a cool tool. I like it a lot. Makes it easy to look at stuff. Oh, here it is, maybe, yeah. So it'll give you like, you can say that your slope is about 0. Well, I don't know, 0.2 to 0.8. I think it's not getting a very good slope. Let's do non-interpolated profile and see what we get for slope. Yeah, I was thinking 0.16, 0.2, 0.21. That looks a little bit better to me. Anyway, so let's see if this is done. Nope, not quite. Let me pause the video until that's done, and then I'll come back and we can take a quick look at some of those results in that channel as well. Okay, so the run is finished. You can either repeat the entire review that was performed in the previous video and just check and see what the differences are. All I want to do is just kind of give a nice little scan of the floodplain of the hydrographs. So let's just grab that. Oops, wrong one. Let's just grab these two. I don't know if this one will even work on a trap channel. I haven't tried it in a long time. I haven't done a trap channel in a long time. So let's check the hydrog, and we're just going to start from the one, and we had about 400 CFS in the previous model. The dimensions are basically the same. And there's rainfall on this too, so it should be increasing as you go downstream. That's probably what this guy is. The two peaks are going to be slightly different. And then you should be getting more volume as you go downstream because the rainfall is starting to fill. If you had the storm drain on, there'd be a lot more water in the channel. Be getting closer to 3,000 cubic feet per second. Because this channel has water coming from the south and from the north. Yeah, it looks pretty good though. And so same thing, you check that. Let's see if the profile will work. Check your profiles. Well, they look good. They look about the same. Whoops. I didn't mean to do peak discharge. Yeah, that's funny. That does your rainfall. Let's go to the next one. And that one looks fine. Oh, a little bit of something going on right here. So be careful of that kind of stuff on a trap channel, because a trap channel, the bed elevation comes from the bank elevation, the lowest bank elevation minus the depth. So we need to make this one deeper. That is 18015. Let's check the next one. And same thing here. That is not accurate. So this one is too low. That one needs to go up. Or we need to make it deeper, or make it less deep because of that one. So, but other than that, these look okay. All right, so let's kick 18015, I think is the one we had, 18015. And that one was, it's actually the next one down. Is it that one? Or is it no, it's this one. It's that one right there. And it's this guy right here. So all you got to do is just 1405.63, and that'll sort that out. And then the next issue was this one, 1403. So just make that 1403. Whoops, not. And that'll sort that one out. And then you can just export it again and check your profile again. And then if you have to do like some minor manipulations, you might want to do your manipulations like down here in this guy. If you have to do minor manipulations because you put all that data in there and you don't want to like lose it, you put these guys in here new, so you don't want to lose those by running that interpolator again. So instead, you do your manipulation in here on your bank elevations. All right, so that's that. I don't think I have anything else to show you. Everything else will be about the same as far as the review goes. So we'll just, I'm not going to redo the whole review. I'll go ahead and stop the video here and post all these videos to the webinar or to the training tutorial page.